All right, hello everyone. Hope you're having a great day again. I probably say that every single time. I am upping my game when it comes to my high-tech classroom recording studio. I totally forgot I had all these from last year. These are whiteboards that when you guys are here back in person, you'll be able to use these for practice and on computer assignments. And I have 3 questions for you guys, one on each one to save some time, that I want to go over with you, all right? I did get a few emails yesterday about requesting extra help or assistance, and if there's any YouTube video you can watch. Excuse me. And I did say, okay, if you want, there are YouTube videos, other ones out there, but if you want to watch something that's specific to us, you can just wait for my YouTube video because I always want to do this for you guys. And I want you to know these 3 that we're doing are exactly the homework questions on the quizzes. So the homework assignment was on quizzes.com. If the questions are not in random order, I don't know if they are or not, so I couldn't really tell on that, but these you'll find are 3 of the exact sets of problems that you'll find on the quizzes, okay? And so if you needed help on the quizzes assignment, these 3 that I'm doing right now are exactly it, okay? So this is question number 2. So let's see. All right, there we go. All right, so this is a multi-step inequality. We know it's an inequality because of our less than sign right there. And like I was saying in our lesson, anytime that we have any multi-step inequality, we want to solve it initially the exact same way as we would with any equation. So if you want to pretend in your mind for a little bit, there's an equal to sign right there and just solve the equation for x, you can do that. But we know that with an inequality, there are some special rules that follows with it. For example, when we divide by a negative, like I was saying yesterday, it flips the sign. And then after we solve for it, after we solve the inequality, our next step is to graph it, right? So we're not done after solving, we have to graph it. Excuse me. Okay, here we go. This is number 2. So when I'm looking at this, I always recommend, especially with inequalities, getting the variable over to the left side. Because as you guys know, and I've said it in the Zoom classes, when our variable is solved and listed first, it is so easy to graph because with our variable listed first, the inequality points us where we're graphing, okay? So in this case, always, no matter what we get, always move your variables over to the left side. So, okay, this variable on the right side of the equation, we want to get rid of it on that side and move it over. So we're going to add 3x to do that. Boom, boom, that automatically gets rid of it. But because it follows the same rules, what we do to one side of the equation, or the inequality, we have to do to the other side. If we added 3x there, we add 3x here. These are like terms, obviously. 2x plus 3x is 5x. Drop down my inequality. That hasn't changed at all yet. The only thing that's left is 15. So I'm going to do that. And then finally, my x is not by itself yet. I need to isolate that variable, get it all by itself. If that's being multiplied by 5, I'm going to divide by 5. Divide by 5. Cancel out. X is less than 3. 15 divided by 5 is 3. Okay? So this tells us the solution set to this inequality is anything that's less than 3. Notice it doesn't include 3 because there's no equal to sign right there, all right? X is less than 3. Let's just test that real quick. 5x is less than 15. Any number that's less than 3 should give us a true statement, right? Well, what's less than 3? Well, 2 is less than 3. Let's plug in 2 for 5. Okay, 5 times 2 is 10. Is 10 less than 15? Heck yes, it is. So we know we found our solution set. X is less than 3. Now we're not done because we have to graph it. And if you're making your own number line, just give me a few ticks, a few tally marks. You know, if this is 0, 1, 2, 3, something like that. You don't have to go crazy. X is less than 3. Let's graph it. We circle, first step, we circle our marker, our 3 right there. We circle it. Step 2, we decide whether it's an open circle or a closed circle. Well, there's no equal to sign, so it's an open circle. It does not include 3. X is less than 3. This is why I recommend getting the variable first, because this inequality sign, this less than sign, literally points to the left. So we're graphing to the left, which makes sense because all these numbers satisfy this solution. 2 we just tried, 1, 0, and so on to negative infinity. Okay, so there is our first solution to question number 2. Okay, I'm going to move it. Told you I'm getting high tech here, people. Here we go. Let me see if it fits. Yep. Thank you guys so much for watching. I really hope this helps. All right, this is a good question. This is near a Super Bowl question. There's a couple things that we got to go over on this. So we have 2x minus 3 is greater than or equal to 4x minus 1. We want to see what group of numbers satisfies this inequality. All right, and we have to solve for x, just the kind of the same thing that we've been doing. And you guys have been doing this all year so far. Just, quote, solving an equation, but now it's with an inequality. Okay, we want to get the variables on the left. All right, let's just get in the habit of getting them on the left, especially with inequalities, because it's easier to graph. I want to get rid of that positive 4 that's on the right. So I'm going to totally just get rid of that by subtracting negative 4. Subtracting negative 4 to the other like term on the left side. 2x minus 4x is, well, 2 minus 4 is negative 2x. Already, that's a red flag because I'm seeing eventually, to get the x by itself, eventually I'm going to have to divide by a negative number. And so my sign eventually is going to flip. So, but we'll work this out and we'll come to that conclusion in a little bit. Negative 2x, okay, we're good there. If my variables are on the left, I have to get my regular constants, my numbers, on the right. So I want to get rid of that negative 3. I'm going to add 3. Okay, those cancel out. I'm going to add 3 right there. Negative 1 plus 3, which is the same thing as 3 minus 1, is 2, positive 2. So I'm going to drop down my inequality sign right there. It's, that hasn't changed yet. Greater than or equal to, drop down greater than or equal to. My x is not by itself. I have to get the x by itself, okay? So to do that, I'm going to divide by a negative 2. Ding, 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 ding. Red flags, explosions, whatever. We just divided by a negative, so that means my sign is going to change. My sign is going to flip, my inequality sign. So here we go. Divided by negative 2 on both sides. X, I'm going to flip the sign. 2 divided by negative 2 is negative 1. It's okay if we get a negative answer. I know I went over this in the Zoom class yesterday because, that's just our number, our marker right there. We did divide by a negative. We flip the sign. If we divide by a positive, nothing changes. The only thing that changes is when we divide or multiply by a negative. Okay, so here's my solution set. X is less than or equal to negative 1. All right, let's do a quick test. Negative 2, I'll just use this equation. Negative 2x is greater than or equal to 2. This is before we divide it. I'm going to just fill in a number, see if it works. What is any number that's less than negative 1? Well, less than negative 1, that keeps going in the negative direction. Negative 2. Negative 2 is less than negative 1. Let's test it. If we plug in negative 2 for x, right there, well, there's a negative 2 right there. What's negative 2 times negative 2? Positive 4. Is positive 4 greater than or equal to 2? Yes, it is. So we just plugged in our solution set and it worked, all right? So notice I used this equation. If you do a test equation, do it, one of the original equations. I could even use this original equation, but there's a lot of math up there. If you do a test equation, use like that. And then after you flip the sign, plug in a number that satisfies that and see if you get a true answer, right? Really, if you do this, 100% guaranteed if you get on the test, if you do it correctly. Okay, now let's graph it. We know that this is our answer. So I'm going to have 1, 0, negative 1, negative 2, negative 3. Something, if you write a number line, something simple like that. Here we go. Let's graph it. Negative 1, there's our marker. First step, I'm going to circle it. Second step, is it open or closed? It is a closed circle, which includes negative 1 because it could be less than or equal to. And once again, my variable is listed first. I did that for a reason because it is pointing to the left, which makes sense because it's everything that is less than negative 1. There's my solution. That was number 5 on the homework. Last one. This is another one of these Super Bowl questions. Here we go. Boom. This is, if it's not in random order, question number 10. Okay? Well, we got to solve this. We're just same process. Solve for x, get x by itself, get the inequality, and graph it. All right? We have parentheses. So that means we're going to use the distributive property. Sweet. I'm hoping 100% of you guys are solid with the distributive property. So I'm going to do it on the bottom this time. Double rainbow, distributive property. Okay. 3 times x is 3x. Right now I'm just simplifying. 3 times negative 3 is negative 9. That less than or equal to sign hasn't changed. I dropped that down. 2 times x is 2x. 2 times 2 is positive 4. Okay, so far so good. Now this looks exactly like what we just did, right? Follow the consistency. Let's get all the x's on the left so it's easier to graph. So this x, 2x on the right, I'm going to get rid of it. Poof, gone. But I'm going to keep my property of equality the same. I'm going to subtract 2x over here. 3x minus 2x is 1x. I'm not going to put the 1. I don't need to put the 1. If there's ever a variable by itself, that coefficient right there is always going to be 1 if it's by itself, which is great because automatically, look at that. I'm not going to have to divide by anything. There's no coefficient right there. I'm not going to have to divide by anything. Nice. So 3x minus 2x is 1x right there. I want to get rid of that negative 9 by doing the opposite of it. Negative 9 plus 9 cancel out. 4 plus 9 is 13. Did I divide anything by a negative? Nope, nothing whatsoever. I don't even need to divide because it's just a 1 right there. So my less than or equal to sign doesn't change. There is my solution. X is less than or equal to 13. Now let's graph it. I'm going to put a marker of 0 over here so I know where it is on my number line. But I'm just going to do, doesn't matter really the space right there. 12, 13, 14, 15, 12. I'm just creating my own number line, 14, 15. X is less than or equal to 13. Step 1, circle our marker. That's that number right there. Is it step 2? Is it open or closed? There's a less than or equal to sign, so it is closed. And all 3 of these were less than signs. What are the odds? All 3 of them are pointing to the left, but that's just it. If this was a greater than sign, we would be going to the right. But since my variable is listed first, it's less than, pointing to the left. I am graphing to the left. So any number that's 13 or less would satisfy this inequality. Okay? Really hope that helped, guys. Tomorrow, we're going to go over this again. This is in preparation for compound inequalities and absolute value inequalities. Which gets a little more tricky, especially with absolute value inequalities, right? If you thought absolute value equations were tricky, just wait. But anyway, I'm here for you guys. Okay. Hopefully it wasn't too long, 13 minutes again. Okay, thank you.